Okay, so today we are going to talk about garbage collection in JVM. Garbage collection GC is a form of automatic memory management. Its aim is to reclaim garbage or memory occupied by objects that are no longer in use by the program. Garbage collection was invented by John McCarthy around 1959 to simplify manual management, memory management in Lisp. It has a longer history than Java. So how to identify garbage? Uh, there are several garbage collection schemes. Reference counting. Reference counting is a simple but slow scheme. In this scheme, each object contains a reference counter. Every time a reference is attached to that object, its reference counter is increased. Every time a reference goes out or is set to none, its counter is decreased. Once the reference count of an object becomes zero, that storage will be released. But one shortcoming is that if objects circulate refers to each other, they can have non-zero reference counts. Let's take a look at classic examples that proves why the JVM doesn't use reference counting for garbage collection. In this code, we create two objects, A and B, and both instances of the reference GC class. Then we make them reference each other by setting A.instance equals B and B.instance equals A. And now here is the key. After that, we set both A and B to none, which means there are no more external references to these two objects. But if the JVM use reference counting, these two objects will never be collected. Why? Because each still has a reference pointing to others. So their reference count never drop to zero. So this is a classic circular reference trap that reference counting cannot handle. Fortunately, the JVM uses a more robust method called reachability analysis, which starts from GC loops and works the reference graphs. It correctly identifies that this pair of objects is unreachable and safely collect them. This example clearly shows why modern garbage collectors don't rely on reference counting alone. So, reachability analysis. The basic idea of reachability analysis is to trace which objects are reachable by a chain of references from root object. The root is called GC root, and the path from the root to the certain object is called reference chain. If one object cannot be reachable from any GC root, it will be considered as garbage, and the storage will be released. This diagram shows a GC root site at the top, from which object references originate. Objects that are reachable from GC roots, directly or indirectly, are marked in blue. These are considered alive and are not eligible for garbage collection. Objects not connected to any GC root, shown in gray, are considered unreachable and can be safely collected by garbage collector. This is essence of the reachability analysis algorithm used in JVM GC. In Java, there are four types of objects can be used as GC roots. Local variable in active stack frames, static fields of loaded class, JNI references, and or native method references, uh, Java threads, and stack frames. Let's look at another example of how the JVM determines which objects should stay alive and which should be garbage collected using reachability analysis. In this code, we defined a class called reachability analysis GC. It has static fields, a final static field, and a normal reference in the main method. Inside the main, we first create an object instance of reachability analysis GC and assign it to a local variable named IGC. That is stored on the stack, so it is reachable from the thread local variables, which is GC root. Then we create another object and assign it to the static field static member, because static member is a class level static variable. It is stored in the method area and is also considered a GC root. We also have a final static field called final member, which points to an object that is always reachable. This is another GC root reference. Finally, when we set IGC to none, the first object is no longer referenced by anything, and unless it is referenced directly from the GC roots, it becomes eligible for garbage collection. This simple example shows how different types of which reference inactive with GC roots and how reachabilities not reference counting help the JVM decide which stay and what goes.